Good. It tastes really nice for like 5 seconds, and then it just sucks. You want some more? I can see that going to a show.
That is called a camera. It used to videotape, but now it's digitizing you.
What? It's taking
For a video record. So it can show your parents how you act in class. Boy, I hate to be your mom.
Oh, yeah, you would have.
Ian, you ready?
Yeah.
Yeah? Huh? We're waiting for you. Just stop spending that 5 minutes second period with your girlfriend.
Yes.
Okay. You have a lot to do. I haven't even looked at your tests. I probably will finish them over the weekend. Mostly because there is, I hear there's a calculus test on Wednesday. So we're kind of zoned into that. Once calculus is over Wednesday, I am also free 4th period.
So then we get your attention.
Now you always have my undivided attention in this period.
But then outside it will be.
As soon as you walk out the door, I forget your names.
Okay. But what about when we're running on the track?
Oh, I remember you again. Okay, now, if you notice the bottom left-hand corner, it says Montgomery County Public Schools, copyright 1314. I believe that's this year. And on top, it says Honors Pre-Cal B. Okay, so you are going to be provided all of the formulas on the front. Now, I was going to give you this yesterday, but the test took a little longer than I thought, and I wanted you to go through this and just check off the ones we've done. This is not the point now, but I wanted to give this to you so that you had them if you wanted to look at it. What formulas on here have we not done on the front page?
Permutations.
Permutations and combinations. Okay, page 2. Yep. What formulas have we not done? Sum of infinite geometric series and binomial theorem. So we've actually done most of it. Now, if you really analyze it, we've done a lot more. We're in conics and 3-space. We talked a little bit about rotations to axes. We talked a lot about degenerates. We're about to do quadric surfaces in 3-space. We touched on 3-space. So if you look at page 3, we did it. If you look at page 4, we did it. If you look at page 5, we did it. If you look at page 6, we did it. If you look at page 7, we did it. If you look at page 8, we've almost done it. We've kind of done it. We did 39. We did 40. We didn't do 41. But it takes about 2 seconds to do 41 after I do conics. Turns out that 41 is a conic in parametric. So it's nice to do conics in rectangular so that you have something to lean on there. We don't have to do conics in rectangular, but we do have to do them in parametric. Okay, so there's only one problem so far we didn't do, 41, right? Okay, so we did all of page 9. We did all of page, no, we've done the 55. 56, well actually starting at 56, we didn't do it. Okay, so starting at 56, we haven't done polar, that's 56 and 57. Starting at 67, we haven't done that, and then starting at 75 is series. We did do 86. What is the distance from the point to the line? AX1. But we did a lot more. We did a lot more 3-space. We did a lot more systems. We did equations of lines and planes and parametric. We did a lot more than is on here. So, as soon as we get through three-space conics, today and tomorrow, Monday test-ish on that, then I'm going to totally change the focus, and we're going to only focus on this. We're going to prep you for the test, okay? And we're going to ignore all the things that are water under the bridge is good for you, okay? We good? Now, I have answers. So, I wouldn't necessarily start this now. I do have answers. However, you're probably not ready for answers. Just don't lose it. If you lose it, no big deal, they're online. I think this is online. Okay. Quadric surfaces. ax squared plus bxy plus cy squared plus bx plus ey plus f equals 0 is what? General form of it's got an equal sign in it. What do we call that?
An equation.
An equation. And how many variables? 2. What type of equation in 2 variables? What's the highest exponent? 2. Second degree equation. That is the general form of a second degree equation in 2 variables. There is no other things you can add. However, some of those turn out to be the classic conics, some of them turn out to be degenerate, and some of them are rotated. Okay? This is the rotation. We didn't spend much time on it. So if this isn't here, these are your translations. Now, if we pump this up to the general second degree equation in 3 variables, there could be an x squared, a y squared, a z squared, an xy, an xz, and a yz. An x, a y, a z, and a constant. So if I'm counting right, there could be 10 terms. But we didn't even touch rotations in 2 space, so I doubt we're going to do a triple rotation in 3 space. And the whole point of this is just to give you an idea of the classic quadric surfaces, so we're probably not even going to complete the square much. Okay, so we're going to start with some simple ones now. So the second degree equation, most of the ones you're going to be doing are going to be ax squared. I'm not going to even do the xy's or any of that. Plus by squared plus cz squared. You might have an x. I guess it would be d, e, f, x, y, y, z. What am I missing? X, y, y, z, x, z. So that's d, e, f, g, dot, 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 g, x, plus g, h, y, i, k. So I skipped those rotation terms. Now you're probably not even going to see these. Okay. What is it that you do? You do the 3 traces. You put in, this is how to graph these. How to graph in 3 space. We've kind of done it. You do x equals 0, y equals 0, and z equals 0. That gives you the equations of the 3 traces. X equals 0 is going to be the yz trace, right? This one's going to be the yz trace. This one's going to be the xz trace. This one's going to be the xy trace. Now, when you do that, you're going to do 3 separate 2-space graphs, just like we kind of did with the sphere, except they're all circles. Then you're just going to look at them. Okay. Some of you're going to look for conics. They may be degenerate, they may not. If they're degenerate, then you go, oh, nothing there, unless it's 2 lines or something. So then, once you do that, you're going to do the YZ trace first. So this is 1. 2. Do the YZ trace on YZ, somewhat to scale. Then what you're going to do is you're going to look for circles or ellipses. What's plural for ellipse? How do you know? Oh, you are a genius. Really? Oh, I like your glasses. Oh, you are. Then you're going to put that in on here. Now, when you put in a circle or ellipse, let's say we have a sphere, that's YZ. The equator is going to be XY. Regardless of what that is, a circle or ellipse, you're always going to do the XY trace to look like the equator. And then the longitude for a circle or an ellipse is going to be the XZ trace. Okay, so this is always going to be XY, this is always going to be XZ, and YZ is going to be somewhat to scale. Then, after you look for your circles and ellipses, you're going to do a second part of that. That's like 3A or 3B. Let's say x equals 0 gives you this. Then you're going to let x equal numbers to see what happens. I used to say, let them run. And what that means is you're going to substitute in values for whatever variable equals 0 here to see what happens to the shape as it changes. This is going to make more sense in a minute. Then 4, you put the last trace in. Remember, there's 3 traces. 1, 2, 3. Okay, example 1. You guys stunk up the place. There's a lot of pressure on it.
That plus is really hard.
Was it? I thought it was bad. Oh, guess what hint I was going to give?
What?
When you do Eulers and you go left, you got to use negative x's.
I knew that.
Oh, I'm so proud of you. What problem were we doing? Oh. 3x squared plus 4y squared plus 6z squared minus 12 equals 0. Okay, so if that was 2 space, what would you say?
A sphere.
Is it 3?
No.
Ellipse,
Space. So it's 2 space. So it's a circle.
ellipse, ellipse, ellipsoid.
Yeah.
Okay, so how do you handle an ellipse in 2 space? Bring over the 12 and divide through by it. So you have 3x squared over 12 plus 4y squared over 12 plus 6z squared over 12 equals 1. Now it looks like it's in standard ellipse form. One more step. X squared over 4 plus y squared over 3 plus z squared over 2 equals 1. So you have to get it in graphing form. The easiest one is the sphere. The next easiest one is an ellipsoid. Football. Spiral. End over end. Okay. What do we do first? Well, we do all the traces first. Then we're going to do YZ. Okay, so we'll do this slow for the first one. YZ trace. Doesn't matter what order you do them in here. It is so humid in here.
It is so humid. It feels like a rainforest.
I know, and the chalk is really soft.
Why is it so humid?
Because the air molecules are heavy. Because our hair is curly. Because our noses are shiny. Because it was so cold in here yesterday, we put all these heavy clothes on, and now it's hot. We're all sweating.
Warming.
Okay, global warming. Oh, thank you. X equals 0. Well, you're smarter than the rest of us. X equals 0. Y squared over 3 plus z squared over 2 equals 1. Any question on the YZ trace?
Is it always going to be the white?
No, you're going to do all 3 of them. When x equals 0, it's always going to be the YZ trace.
You always do that one first.
No, it doesn't matter. When you graph it, you're going to do that one first. Now, the intersection of this plane and this next shape is this ellipse. Okay, so you draw it in two space. YZ, you probably put Y to the right and Z on top.
Yeah.
Yeah? And y-intercept is root 3. Z-intercept is root 2. Root 2, root 3. So this is root 3. This is root 2. This is negative root 2. This is negative root 3. What trace you want to do next?
X, Y,
X, Y. So that means Z equals 0. X, Y. X squared over 4 plus Y squared over 3 equals 1. Your old buddy X, Y. X-intercepts are plus or minus 2. Y-intercepts are plus or minus 3. Root 3. So there's root 3. There's 2. Root 3 is 1.7. It's rounder than that. So what? What's next? X equals 0, Z equals 0, Y equals 0. Y equals 0 is the XZ trace. XZ. X squared over 4 plus Z squared over 2 equals 1. X intercepts are X, X, Y, Y, Z, X, X. What is that? Z, yeah, root 2 and Z. And 2 and X. Okay, now, what trace do you do first? Oh my goodness sakes.
yes. Yes.
I mean, I finally made it.
You missed.
I haven't missed all year.
You did it like once, and then you missed it.
Barry, thank you for pointing out my faults and all my errors. What?
That's what you do when you grade the papers.
Because I'm old.
Mr. Mosher did it for you.
Yeah, Mr. Mosher.
No,
Mr. Mosher is under 35. That's why he can't be president
Oh,
yet.
Yeah.
true, right.
Exactly.
He wasn't born in the United States, that's why.
No, he is. He's just not 35 yet.
Oh, thank you. Can we move on?
Yeah.
Okay. We're playing football here. This is an ellipsoid, not a spheroid.
Not bad.
Okay, so YZ trace first, somewhat to scale. YZ trace. Root 3 is bigger than root 2, right?
Yeah. Really?
Okay, so this is 2. So, where am I? Root 3 and Y. 1.7?
Yeah.
So that's root 3, negative root 3. What are the Z-intercepts? Root 2 and root 2. 1.4, 1.4. So roughly to scale, and try, it doesn't really matter how you draw it, just try to get it as symmetrical as possible. This is 0, root 2, 0. This intercept is negative, or 0, negative root 2, 0. What's this one?
0, negative.
I screwed up.
No, it's root.
I have a mistake. Where's the mistake?
It's root
It's root 3. These are
0, 0.
negative, these are root 2. Negative root 2, 0, 0, negative root 2. Okay, now, what do you know? What did we put in for x to get this? Right? So, this point here is 0, root 3, z is 0. So this point is this point. Okay? Where's your other root 3 and y? Right there. Okay. What did we put in for z here? 0. And what do we put in for x to get the y-intercept? So this point and this point are exactly the same point for exactly the same reason. So that means that this ellipse is drawn on the board. This is the YZ trace. This is the XY trace. What shape is this? Ellipse. What are you going to draw it as?
Circle.
An equator. Does it matter which one's bigger? No. Don't draw it outside because the x-intercept is bigger. So you always draw the equator regardless of what the ellipse looks like. So I have to put an equator in here. right, I'm putting it like this, just because that really looks good. Okay, got the equator in. We don't have the x-axis in, we'll put that in last. We'll fudge that to fit. This ellipse is this ellipse. And this is the biggest number, 2. Okay, what do we have to put in now? Oh, wait a minute. We're here. So we put in the YZ trace first. Then I look for ellipses to circle. It doesn't matter. All I have in an ellipsoid is ellipses. So you don't really have to worry about this. So you're going to put one of these ellipses in as the equator, and one of these ellipses in as the longitude line. Doesn't matter, because an ellipsoid is easy. You're not fighting it. There's no degenerates. We can put the last trace in now. It's going to look like longitude. Let's do it. So we did that one. We did this one. We're doing this one. What shape is this? An ellipse. And it's in what plane? XZ. So that means it's coming out at you this way. So the ellipse is going this way somehow. So you just draw it that way. That way. However you want. But whatever you make the right side, make the left side. Now you put in your axes. You have 2 of the axes in. You're missing which axes? X. So, this point here is what? 2, 0, 0. This point here is 2, 0, 0. So that means the intersection of the XY trace, the XY trace, and the XZ trace intersect at the x-intercepts. Oh, so that point there is 2, 0, 0. And if you go backwards, that point there is negative 2, 0, 0. It is hot in here. Thanks for reminding me. I was comfortable. Okay.
No.
Like,
Or actually, there's sunny.
Oh, a rainbow!
Wait, really?
No! It's snowing!
Oh, that I know.
It's windy! It's gorgeous. Can we go outside?
Yes!
Oh!
We can use a real football.
Oh!
Yeah!
Oh, we're done with the football. We're going on the harder ones now.
hands-on.
Wait,
A
okay.
basketball.
Okay, question.
Why is that? Like, how can just
Oh, okay. Barry's on to something. Verbalize it.
you flipped things?
No, I didn't.
You flipped
did.
yourself.
No, I didn't. It's perspective. When you stand, let's say you're in Kansas, just because it's really boring there and you have a lot of time on your hands, and you're in the middle of the train tracks, and they're really straight, they're not following the rivers and the base of mountains. They're really, really straight. So when you look down those train tracks, the tracks get closer together. So obviously, the wheels slide in on the axles or the train would get stuck.
No, that's not right.
What's not right about that?
It's just
Perspective.
Yeah.
The perspective is off. This distance here is your biggest distance. That's bothering you. I'm guessing. Okay, so it comes out this way. So what? But if you draw this outside, you can't. When the x-axis is coming out at you,
Draw it outside.
an inch looks really small from where you're sitting. That's all.
But like, it doesn't actually. Like, how does
If
it
you got
actually?
draw right there, it's not be.
The football is long this way. Actually, a football is a circle this way and long one way. This isn't a circle in any way. This ellipse is the biggest one. Yeah. That's an ellipsoid. Now, you do need to know the names. Why is this important? Well, first of all, I like it. Second of all, when you go to calculus and you use, this is your favorite thing, and you use an infinite amount of thin areas, like all the pages in a book, you actually get a volume. And in calculus, you can do something called integration, and you can integrate areas to get volumes. if you can picture the three-spacey thing that we're doing, it helps you when you work in two-space calculus to get a three-space answer.
Man, I actually made.
What else can they? No, it didn't?
No, I didn't.
Okay. All these pages in the book, they're all areas, right? And they're all two-space, right? But if you add up infinitely many, infinitely thin ones, you actually get a volume. Oh, yes they are.
Ever tried measuring one?
Measure that for me. You don't have a ruler? Oh, we got time. Measure the thickness of that paper for me.
Making a fool out of Ryan is the most enjoyable part of this class.
Don't leave camera now.
It's actually
But I think it's easier
No,
to make a
wait,
fool
no,
out of
no, we need
Ryan.
some.
You sure?
Because he does it himself.
Oh.
Yeah, he-
Like I said.
It's all blankets.
Okay.
You said
Symmetry. Now, when you're in two
Thanks for
space,
having my back.
when you're in two space, if you have a circle, any line through the center is an axis of symmetry. If you have a sphere, any plane through the center is an axis of symmetry. So you're up a dimension when you're in three space. So any plane here through the center, would that be, I don't know. How about this? The XZ plane definitely cuts this in half. So any coordinate plane, x, y, y, z, or xz, is actually a plane of symmetry there. There's also lines of symmetry. The x-axis, the y-axis, or the z-axis would be lines of symmetry. Okay, ready for another one?
We're gonna
Yay.
do hyperboloid.
Hyperboloid.
No.
I don't think just this.
Okay, hyperboloid.
Wait, it's actually called a hyperboloid.
Of course it is.
It's just two satellites that I draw.
Oh,
Need a perfect square.
I was thinking parabola.
4. Another perfect square.
225. Get to you.
More often.
Hold on, 225.
Hyperboloid.
Thanks, Cameron.
No, like.
You should have gone with 6.
No.
They go 3 quarters. Or 2, 3.
Okay. Now, I want to go through the two space fast because I want to go through some examples so you can do them. I'm just going to do xy real quick. xy, z equals 0, right? X squared over 4 plus y squared over 9 equals 1. X1, ellipse. What are the intercepts?
2, -4, and 3.
So it looks something like this, right? So this is 2, this is -2, this is 3, this is -3. That is the xy trace.
Wait, I got it. Why is it a plus?
I changed it. Y z trace. Y squared over 9 minus z squared over 25 equals 1. Now I put these in graphing form to just speed it up. Okay, so YZ. That's a hyperbola. And which way is it opening in that two space?
Upwards.
No.
Y is positive, Y is now a horizontal.
Aha, aha.
You can do it this way. Put in 0 for Z and X. The y-intercepts are plus or minus 3. What are the z-intercepts? None, don't exist. So it has to go like this. Don't worry about the asymptotes anymore. This -3 is this -3, and this +3 is this +3 on the y-axis. Okay, what's next? X, Y, Y, Z, X, Z. Y equals 0. X squared over 4 minus Z squared over 25 equals 1. Okay, XZ, what shape? Hyperbola, open in which way? On this one. Which one's positive? X.
Still
So
opening to the side.
this point is 2, this point is -2. So these intercepts are the same intercepts as these, and these y-intercepts are the same intercepts as these. Because if you put in x equals 0 and z equals 0 in, you get the same 2 plus or minus 3 and y, and so on and so on.
So like basically that it was hyperbolas are like coming together.
Yeah, they're going to the prom. Okay? So, what do we do first?
Use the trace.
YZ trace. Now, it takes some practice in that you don't know how fat or wide to make them. if you make them too fat or too thin, you can just redo it. Don't worry about it. So YZ. You might not want to make this one too much to scale, because it depends on which way it's flipping and all that. Okay, YZ. This one, right? So I'm going to roughly draw them. This is 3, 3, 1, 2, 3. How in the world did you know dx was negative? How'd you do that?
Because you're going from 0 to -1.
Yeah, but we never did that one before. Otherwise, you have a sign error on slopes.
Yeah.
Isn't that weird? Okay, so, oops. This one looks, who drew this? They gotta look the same. I didn't change it. They look symmetrical now? That's not funny. Can you relax?
Yeah.
Good, me too. Okay, so, YZ's done. What do we do next? I'm covering up the answer.
It's okay.
You look for the circles or the ellipses. Not this one. This one. Okay. XY, circle or ellipse, looks like what on the globe? Oh, I'm drawing an equator. Why? Because I told you to. Don't even think. Yes, it is. Yes, it is.
You're not the government.
Okay.
Cameron, that shouldn't be a problem.
Cylinder,
But like this.
kind of, like 3 Mile Island.
Like a
Nothing.
volcano.
You weren't born yet. Like a volcano.
Except
Okay, so here's the problem. How did we get that ellipse I just drew? Don't say drew the equator. Where did it come from? How did we get that?
Wait, but you changed it.
It's perspective.
Where did that ellipse come from? Z equals 0. So what you want to do is plug in something other than Z equals 0 now to see what happens. If you plug in Z equals positive, which way are you moving? Up. If you put in Z equals negative, which way are you moving? So you want to see what happens to this figure when you move away from the XY plane. Okay, so pick a number to put in for Z.
13.
I'm not putting in anything. How about that?
5.
Wait, why?
You can put in a number if you want. Put in 5. Good idea.
Yeah, because it makes it. Wait, is that a 5 or 2?
I have no idea. Okay, if you put in 5, isn't this a 2?
Yes.
Yes.
If you put in negative 5, isn't this a 2? If this is a 2, don't you divide both sides by 2 and that becomes an 8 and that becomes an 18? If you put in Z equals 10, isn't this a bigger number? When you divide through by it, aren't these bigger? So the further away from 0 that you get upward, what happens to the ellipse? Bigger. It's bigger. This number gets bigger, this number gets bigger. So you draw the equator up bigger.
Whoa.
And down bigger. Z is 2.
It's like an hour.
The ellipse gets bigger.
I told you.
Camera's not on their faces, it's on the wrong thing.
Looks like a nuclear
Well, I
reactor.
was thinking.
True.
That's why he said 3 Mile Island.
So, you can you can put in points if you want, if you're shaky. Now, last thing. I let Z go positive 2 and negative 2. The ellipses got bigger. They were parallel to the XY planes, so they look really flat, which means they look like equators. Yes, Daniel?
What happened to the last hyperbola?
We're good.
We're doing that now.
Yeah, Dave.
So we need to put in our x-axis. You tell me where. How about here?
Sure.
Now, what you want to do is find the centers of those other conics you put in. Z, parallel to Y, parallel, this scale's too big. Parallel to X. Now, we haven't put this one in, right? I know, I can't, because we didn't put this in. Now, this is going to look like the longitude on the globe, but you have to make it look like this hyperbola. Is this 2 on the x-axis? Is this 2 on the x-axis?
Yeah.
Now, for some z value that's bigger, there's a point here, and for some z value that's the opposite of that, there's a point there. Is this parallel to the z-axis? I didn't put this in. You want to get these x-axes parallel.
Wait, question.
It's not very.
What
That's this hyperbola.
is that down at the bottom?
The parallel to the axes. Now I'm going to put in this one in the back. I can't get the back because it's up there.
The one going
So, if you're looking at this, when z is up and x is on your right, z is up and x is on your right, I'm looking from over here, and I see this part of a hyperbola right here. 2. That's this one. And then the one that's hitting the kid that's sitting in the desk over there, in Ms. Ham's room, is right there. It's hitting him right in the head.
There's no one in the house right now.
Really? That's why they're not complaining? It was last period. We should have done this last period.
Yeah.
That is called a hyperboloid of one sheet. Not like 3 sheets in the wind.
What?
We just call it a hyperbola.
The x-axis.
The x-axes.
Yes.
You can have only one of them. You can't have 2 of them.
Yeah, the x-axis. Why did you put it there? Did it just look good? Like that's where it's supposed to go?
It's looking really good right there. That's why. Oh! I forgot to tell you how I got good at this. Don't tell Ms. Ham's.
Did you do anything?
You cheated.
No. Oh, you gotta tell him. I can't tell you.
I
If you promise not to tell him, I'll tell you.
promise.
Okay.
I promise.
No, I can't tell you. Cameron's-
I give you my.
Okay, okay,
Cameron,
okay,
get out.
okay.
What's
Shh.
your camera?
I can't.
I'm out.
Shh. I practiced.
You realize that was on video, right?
Yeah, so? Video on the film.
True.
Is she gonna get it?
You never know. She
Oh.
could come in and steal it.
Oh, good.
Why is there recording?
Yeah, do you want to explain?
Wait,
You haven't
wait,
noticed
wait.
that this whole
Notice
time?
that?
Honestly, people were staring at the camera, and then he told Ryan to go
And
sit
Brian
down.
was being a
I
fool.
don't
He
even
just like
know.
Ryan's being like,
Why is it there? Right, but specifically when he was.
I don't know. I'm going for my,
Running their own variables.
no, what do you call that thing when you get your 2,000 more dollars?
Scholarship?
No, like master teacher, what do they call it?
Oh, that's an
What do you call that?
Oh,
What, yeah, what do they call that?
Bonus.
money.
Like, you get your, it's like
A lot of
you get
money.
if you're a good teacher or something.
No, you gotta be certified, nationally board certified.
Yeah, that's.
You have to film yourself.
Yeah.
Are you really doing that?
Right.
Like they're gonna.
Yeah, I'm gonna do that and then
I
retire.
was gonna say.
There's an idea.
Doesn't make any sense.
An idea.
You never know.
Why
though.
is never was
I don't
Now there are 2 minuses.
Okay,
That's what it was.
now there's 2 minuses. Now, do this fast. Z squared over 9 minus x squared over 4 equals 1. Z squared minus y, whoa. Z squared over 9 minus y squared over 16 equals 1. What am I missing? X, y. Negative x squared over 4 minus y squared over 16 equals 1. Do I have all the traces right? Okay. XZ. XZ. What shape? Which way? XZ. Which way? Which shape? Hyperbola open to which way? Up. What are the intercepts? 3. What shape? Y, Z. We'll put Y there, Z there. Same thing?
Oh god.
Same way?
Yeah.
How do you catch a tame rabbit?
The same way.
Same way.
That was.
Alexis,
What?
you didn't get that joke last time. Want me to tell you again?
No, I did. I understand that one.
Okay.
Is that
It's just irrelevant.
It's not irrelevant.
The tame
It's a rabbit. It's not an elephant. Come on.
It's degenerate. Minus, 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 plus.
Yeah.
What?
Yeah.
Degenerate.
So that's a degenerate ellipse.
So if I move the 1 over, if I move the negative 1 over,
Yeah.
x squared over 4 plus y squared over 16 equals negative 1. So don't draw anything there. Nothing exists when z equals 0. Ew.
Don't wait.
There was a reason we did degenerates. Now you know.
Did you know that?
What do we do first? What do we do first?
Grab a YZ.
Up. 3, 0, 0, 3. And whatever, try to draw this as symmetrical as you can, although it may not matter. Okay. 0, 0, negative 3. I didn't put any axes in other than YZ. YZ done. What's second step? Look for circles and ellipses.
We don't have any.
Uh-oh.
Uh-oh. Do we have any degenerate ones? Oh, when do we have a degenerate circle or ellipse? When z equals 0. So you want to put in z equals what? Something else.
3.
Did that go in?
I told you you never make it.
Okay,
That's like you made
So-
it disappear.
you want to get z on the other side. Why don't you bring these guys over here and that guy over there?
Well,
Z squared over 9 minus 1 equals x squared over 4 plus y squared over 16. Now, where does this side turn positive? When z equals plus or minus 3. So if you let z,
Greater than slash less than plus minus.
where is it equal to 0? 3.
Plus or minus.
So, when z equals 0, you have nothing. When z equals 0, you have nothing. Don't put anything in there. When z equals 3, you have a what? A point. What's the point? 2, x minus h.
0, 0,
0,
0.
0, 0, 3. Oh, that's this point right here. And what if z is negative 3? You have another point. So you want to let z be something bigger than to get n. And then if this is positive, and this is x squared over something plus y squared over something, and this is a positive number, what do you do with it? You divide by it. And then the bigger that number is, the bigger these denominators are. So that means this is always going to be a squared, bigger and bigger and bigger, and this is going to be b squared, bigger and bigger. So the higher up you go, the bigger the ellipse gets once you get z is greater than 3. How do you draw an ellipse? If z equals 4, what plane are you parallel to? Z equals 4. XY. What does an ellipse look like in XY? Equator. So why don't we draw an equator up here? Because that's bigger than, because this is bigger than 3. Then you find your centers, put in your axes, you find your centers, put in your axes, parallel to x, parallel to x.
You didn't even make the X though.
I just,
Ooh.
but nothing's there. This is x. That's looking really good. So this point, and this point, and this point is this one, and this one is x, -3.
that actually makes sense.
It does. And you got to go off these 3's. Huh. kind of like this.
No.
Yes?
Yeah.
You do like this? Yes?
I just.
This is the first time Jared's been quiet for a whole half hour. He must like this.
He
I think
has
he's
not
just
been
quiet.
quiet.
I like Oscar one.
Yeah, you're.
Yeah, I don't like the
I'm
looks of
sorry.
this.
All my fellows.
Hyperboloid of 2 sheets. Not 3 sheets.
So 2 bowls.
Wait, but
You're going to use that in college probably.
when do you ever
3
need
sheets?
when do you ever need 3 sheets
The
on
first
the bed?
one was 3
You
sheets.
only
Don't.
need 2.
Wait, what?
Why would you? One sheet.
Well, what if you're 3 sheets and you can't get between them? And you need a 3rd sheet.
What if it's 2 sheets and 1?
Oh my God.
We're talking about the gas.
And Jared talks.
Hey, Mr. Dow, do you remember being a freshman?
Vaguely. The fall.
Okay. How many freshman boys,
In high school or college?
college, probably didn't have sheets on their bed by December 1st?
My brother.
11.
Huh?
That's
Wait,
accurate.
why?
Yeah. You don't now? Oh, you do the laundry, huh? You won't. Oh, but you'll be having fun. But you're gonna have to go to your 30 like I did.
Yeah?
No.
It's cold. Don't you have sheets in bed all the time? What? No? I do. I mean, if you're cold.
Here, we're talking about
Because we were talking about sheets.
Yeah, I got that.
I don't know.
But why are we
I
still
still
on that?
Why would you ever need 3 sheets?
One more, can we get it done?
No,
No, we got pushed out all the time.
Okay. Hyperboloid of 2 sheets. Now, you want to look for your degenerates, not your classmates. None of you are degenerates, even though some of you are pretending like you're not on photos.
So sneaky!
Now I know why this is so
No,
hard.
he wasn't actually honest when I was in his pocket.
Really?
What is that?
I think he's doing. Oh, he's making
Right.
It's my idea.
Are you spreading notes to the geometry kids? Okay. Assignment number 3. So who has one of those? I can maybe do it from here. I can't tell by looking at them, but you have answers, right? They're not going to help you.
Not really.
Okay. 1 through 11. Listen, this is a 2-day assignment. You're not going to get all these done tonight. Or do you want me to split them in half?
1 through what? 11?
Okay, 1 through 11 all, that's the next 2 assignments. I'm gonna have to start class, maybe going over some of those. You can get cones, you can get paraboloids.
1 through 11.
1 through 11 all on page 470. Yeah,
It's the back of the first one.
to the back. One through 11 all. It is hot in here.
He wasn't.